All right, so in this lesson, we're going to talk about reference angles, and I'm going to show you how you can calculate the reference angle for any angle measure in either degrees or in radians. So what is a reference angle? Well, here's a great definition. It's very, very simple. It is the acute angle. Now, what is an acute angle? You may or may not remember this. An acute angle is an angle that is more than 0 degrees but less than 90 degrees. Okay? So it has to be your reference angle. Your answer on a reference angle has to be a number that is larger than, well, let's write reference in here. Ref. Your reference angle has to be larger than 0 degrees, but it has to be less than 90 degrees. Okay? Or if you're giving it in radians, it has to be larger than 0 and less than pi over 2. So, if I ask you for a reference angle and you're about to write down 125 degrees, it is already wrong. It has to be a number that falls between 0 and 90 degrees or 0 radians and pi over 2 radians because it has to be an acute angle. Well, where is this acute angle? All right, well, the reference angle is the acute angle that's between the terminal side and the x-axis. And when I say the x-axis, I mean the closest x-axis. So let's do a few examples here. All right, let's say that the terminal side is right here. All right, let's say that this is a 50-degree angle, and this is the, I'll put TS, this is the terminal side, all right, and it's a 50-degree angle. Well, the closest x-axis to this terminal side is the initial side, and therefore, this is the reference angle. So the reference angle is 50 degrees. Well, that was easy, but they're not all going to be just like that. But here's the idea. The idea is that if the terminal side falls in the first quadrant, the reference angle is going to be the angle, either the angle you're given, if it's between 0 and 90 degrees, or if you're given one that's larger than 90 or smaller than 0, then you need to do the coterminal. You either have to add 360 to it or subtract 360 from it until you are between 0 and 90 degrees. Okay? The first quadrant angles are the easiest ones to do because usually the reference angle is what you're looking at. Okay? Or it's just an angle that's coterminal to the angle you're given. All right, well, let's do another one. Now let's do one in the second quadrant. So actually, let me write in here. If theta is between 0 degrees and 90 degrees, that is the reference angle. Okay? All right, good. All right, what if it's between 90 and 180 degrees? Okay? All right, so let's say that here's our angle over here. And let's say that that is a, let's call it a 120 degree angle. Okay? Well, now our terminal side is in the second quadrant, and we want to know where is the reference angle. Okay? Well, again, it's the acute angle that's between the terminal side and the x-axis. Well, if we go from here over to here, that's not an acute angle, but here's the x-axis. So all we have to do is go from the terminal side to the x-axis and create an angle. This is, that right there is the reference angle. Okay, that's the reference angle right here. So if I ask you what is the measure of the reference angle, you may not know how to do this, but we do know that when we go from the initial side over to this side, over to the x-axis on this side, we know that that creates 180 degrees. So we know that this 120 plus the reference angle is going to equal 180 degrees. And so all we have to do is subtract 120 from 180 degrees, and we get our reference angle. And so we just do 180 minus 120, and that equals 60. So our reference angle here is a 60-degree angle, okay? And so if your theta, well, here, let me give you a better procedure here. Step one is always going to be identify the angle that is coterminal and between 0 degrees and 360 degrees, or 0 and 2 pi, which is what we did in the last lesson. In the last lesson, I taught you how to do that. I taught you how to do step one. So that's always the first thing you're going to do. Now, if the angle that you're given is already between 0 and 360, or it's between 0 and 2 pi, then you can skip step one, okay? All right, after you have an angle that's between 0 and 360 and 0 and 2 pi, there are, basically, it depends on what quadrant you're in. The reference angle depends on the quadrant. Now, the first lesson that you learned today was how to identify which quadrant the terminal side is in, okay? On the quadrant, let's say the quadrant of the terminal side. Of the terminal side, okay? So, we already learned that if the terminal side is in quadrant 1, then the angle is the reference angle. Okay? So if your coterminal angle between 0 and 360 or between 0 and 2 pi is either between 0 and 90 or 0 and pi over 2, that's your answer. That is your reference angle. Okay? But if it's in quadrant 2, if your coterminal angle has a terminal side that winds up in quadrant 2, well, then what you have to do is you have to do 180 minus the coterminal angle equals the reference angle. Okay, I'm going to use this symbol as angle, okay? Or 180 is the same thing as pi. You can also do, if it's in radians, you can do pi minus the coterminal angle equals the reference angle. Okay? All right? Well, now let's see what happens if it winds up in quadrant 3. All right, what are we going to do if let's say that our angle is, let's say down here. Let's make it a simple one. Let's make it a 225 degree angle. 225 degrees. Okay? Well, here's the terminal side, and it is closest to the x-axis on the negative side. And therefore, the reference angle is going to be this angle from here to here. That is the reference angle. Okay? And the way I can get this reference angle is this. I know that I went up to 180, but then I went a little further. So if I just take away 180 from my angle, it'll give me what's left, the reference angle. And therefore, if you are in quadrant 3, the way you're going to find the reference angle, I should write it right like this. I'll say that the reference angle is equal to the coterminal angle minus 180. So all you have to do is subtract 180 from the reference angle. 225 minus 180 is equal to 45. So this particular one, we're going to do 225 minus 180 is equal to 45 degrees. Therefore, the reference angle for 225 degrees is a 45 degree angle. Okay? Because that's the angle between the terminal side and the x-axis. Okay? All right, or if you're in radians, then the reference angle is going to be the coterminal angle measure minus pi. So in quadrant 2, we're doing 180 minus the coterminal, and in quadrant 3, we're doing the coterminal angle minus 180. Okay, they're very similar, so don't get them mixed up. Be very careful. All right, last one. What if it's in quadrant 4? What if the terminal side is in quadrant 4? So let's say that our angle is 300 degrees. Okay, so we have a 300-degree angle, goes from here all the way around to here, and that's 300 degrees. So here's our terminal side. Okay. The reference angle is going to be the acute angle that is between the terminal side and the x-axis, which happens to be the initial side, right? So it's going to be this angle measure here. That is going to be the reference angle, okay? All right, well, how can we get this reference angle? Well, if we go all the way around, that's 360. And then if we take away the 300, that will give us what's left over as we approach 360. So the way that you find the reference angle in the fourth quadrant is you do 360 minus your coterminal angle, which is 300, or the coterminal angle of the angle you're dealing with. You might have been given 300 as the question, in which case you just do 360 minus the angle that you're given. But if you were given a 660-degree angle, you had to subtract 360, which then gave you 300 degrees, and that's why 300 is now a coterminal angle, okay? So 360 minus 300 is equal to 60, and that means that this reference angle is a 60-degree angle. Or let's say that you were given it in radians. We would then have to do 2 pi minus, let's see, 300 would be 5 pi over 3 minus 5 pi over 3. Now remember, 2 pi would be the same thing as 6 pi over 3, and 6 pi minus 5 pi is pi. So here the reference angle would be, excuse me, not over 6 over 3. The reference angle would be pi over 3, or the reference angle is 60 degrees. Okay? All right, so let's write this out formally. I'll write it over here because I ran out of room over there. If your terminal side winds up in quadrant 4, then the way you're going to find the reference angle is going to be equal to 360 minus the coterminal angle, or if it's in radians, the reference angle is going to be equal to 2 pi, which is the same as 360, minus the coterminal angle. Okay? Let's do a few examples, shall we? I'll give you a few angle measures, some in degrees, some in radians, and we'll see how we calculate the reference angle. Okay, so I've got 2 here. We're going to try and identify the reference angle of an 850-degree angle and a negative 170-degree angle. Okay? All right, well, 850 degrees is not between 0 and 360, so we need to identify the angle that is coterminal to 850. So we're going to subtract 360. So 850 minus 360 is 490. Got to subtract 360 again. And we get 130. So an 850-degree angle is coterminal to a 130-degree angle. A 130-degree angle is between 90 degrees and 180. That puts it in quadrant 2. And therefore, it's probably somewhere like right here. So this would be the reference angle right there, because this is the 130-degree angle. This is also this terminal side is the same terminal side as 850 degrees. And that's why we can use 130 degrees, because it has the same terminal side as 850 degrees. So we want to find this reference angle down here. And again, we know that we would have made it to 180 and we didn't. So if we take away this angle from 180, it'll give us the reference angle. And look, quadrant 2, 180 minus the coterminal angle. So 180 minus 130 is equal to 50 degrees, and therefore the reference angle for 850 degrees is a 50-degree angle. Now let's do the same thing for a negative 170-degree angle. By the way, you can pause this video anytime you want, work on this before I do it, and then check to see if it's right when I work through it. So this is a negative angle. Therefore, it's not between 0 and 360, so I need to add 360 to it. So we're going to go negative 170 plus 360. That gives me 190. So this is the equivalent of a 190-degree angle. And a 190-degree angle is in the third quadrant because it's a little bit larger than 180 degrees. Therefore, it must be down here somewhere. And therefore, this little tiny angle here is going to be the reference angle. Okay? The whole angle is 190, but this little tiny acute angle, that is our reference angle. And in the third quadrant, what we're going to do to find the reference angle is we're going to take the coterminal angle, which is 190, and subtract away 180 degrees. And 190 minus 180 is 10 degrees. And therefore, the reference angle for a negative 170-degree angle is a 10-degree angle. Okay? Now let's do a couple that are in radians. Okay, so now what we're going to do is we're going to do these two angles that are in radians. And so we got 21 pi over 5. 21 divided by 5 is larger than 4. So this is more than 4 pi. Therefore, we're going to have to subtract 2 pi a couple times to find the coterminal angle in radians. So so we're going to subtract, double the denominator. 5 becomes 10. So subtract 10 pi over 5. And that gives us 21 pi minus 10 pi is 11 pi over 5. 11 divided by 5 is 2 1/5. So that's still larger than 2 pi. So we're going to have to subtract. Actually, I should have put an arrow here. Now we're going to have to subtract 10 pi over 5 again. And 11 minus 10 is 1. So that's 1 pi over 5 or just pi over 5. Okay, so here is our coterminal angle, pi over 5. Okay? Well, pi over 5, that is between, it's already, that's in the first quadrant because it's between 0 and pi over 2. Okay? Because it's 1/5 pi. You know, this would be 1/2 pi. This is 1/5 pi, which is probably maybe right there. Okay? So this is 1/5 pi. It's in the first quadrant. Therefore, that is the reference angle. We don't have to go any further. The reference angle, so 21 pi over 5, is pi over 5. Okay? Now let's do negative 13 pi over 6. This is a negative angle in radians, so we need to add 2 pi. So we're going to add, double the denominator. 6 becomes, doubled becomes 12, so add 12 pi over 6. So negative 13 pi plus 12 pi is just negative 1 pi, or negative pi. So we've got negative pi over 6, still not between 0 and 2 pi, so we're going to add 12 pi over 6 again. And negative pi plus 12 pi is 11 pi. So we have 11 pi over 6. 11 pi over 6 is almost 2 pi, but it's larger than 3 pi over 2. So this is in the fourth quadrant. This is over here. And to be sure, if you wanted to, you could turn this into degrees and it would become a 330-degree angle. And then we would know for sure that it's in the fourth quadrant. Because this angle is in the fourth quadrant, what we have to do to find the reference angle is we have to take 2 pi and subtract away this coterminal angle. Well, 2 pi, to convert this into 2 pi to have a denominator of 6, that's exactly what we were doing before. We need to double the denominator, so we'll do 12 pi over 6 minus 11 pi over 6. And 12 pi minus 11 pi is just 1 pi, or pi, over 6, and therefore the reference angle for negative 13 pi over 6 is pi over 6. Okay? And this is how we calculate reference angles. You may need to watch this video a couple times, possibly, if you were a little confused. But just remember, if your answer is not between 0 and 90, it's already wrong. Okay? All reference angles are acute angles. They all fall between 0 and 90, or 0 and pi over 2, and it is the angle between the terminal side and the x-axis. Okay? All right. Now we're going to move back to triangles. Okay, I know we haven't done triangles yet, but the last time you did trigonometry, you probably did it with triangles. We're going to apply a lot of this knowledge to triangles, and then that is going to lead us into the heart of trigonometry.